Hi, welcome to T4-From. In this lesson, we will learn the perpendicular from a point to a line. We will first see its definition, then we will quickly learn a theorem about it. Let's start with the definition. Let's say that we have a line A in the plane. Let's say that we have a point P, which is not on the line A, and a point H, which is on the line A. Okay? Then the line segment PH, so let's show it. The line segment PH, when I join the point P with point H, is called, is called the perpendicular from point P to the line A if PH, the line PH, you can think about the line PH, or you can just think about the line segment PH, is perpendicular to the line A. Okay, so if you see that PH is perpendicular to A, to the line A, we say that PH, the line segment PH, is the perpendicular from point P to the line A. And in this case, the point H, where PH and A, the line PH or the line segment PH, and the line A intersect, is called, this point H is called the foot of the perpendicular. Okay, that's all. I think there is no need to talk about it more. Let's see our theorem about perpendicular from a point to a line. Okay, this is theorem number 3. I will enumerate all our theorems throughout all our lesson videos in plane geometry series. This is the 4th theorem of the series in our 9th video, right? 9th lesson video. Theorem 4 says, from any point not on a given line, okay, as soon as I read, let me say line A and point P, not on line A, okay, from any point like P, not on a given line like A, it's possible to draw a perpendicular to that line. So from P to the line A, it's possible to draw a perpendicular. And this perpendicular is unique. So there is only one single perpendicular. You cannot draw more than one perpendicular from one point to a line, okay? Just one. So since this is a theorem, it requires proof. Without proof, we cannot trust theorems. But there are 2 parts to prove in this theorem. The first part is we need to prove that it's possible to draw a perpendicular from our point to our line, okay? This is written in A. And the second part of our proof should be, we need to show also that, we need to prove that that perpendicular is unique. So there is only one single perpendicular. Okay, let's start with the with part A. So on the point A, first I'm explaining, then I will write it here. Okay, so on the point A, let's pick a point like A, point A, and draw the ray AP. Okay, and let's say that I have a point, another point B on the line A. I need this point because I will name this angle PAB. So I needed a third point. Okay, so let me write it first. Let A be a, let's write quickly, A and B. Let A and B be 2 points on the line A. Okay, draw the ray AP. Okay, we drew the ray AP. Now we know that we have an angle here which is PAB. Okay, there is an angle here, PAB. This time, again, through the point A, draw another ray. Let's say the ray AC, okay, such that AC is making the same angle with our line A. So such that I'm drawing a ray AC such that the angle CAB equals the angle PAB. Let me show it like that. Okay. So let me write this part as well. Now draw the ray AC such that the angle PAB is equal to, actually if I write it other way, it makes more sense to me, such that angle CAB is equal to the angle PAB. Okay. Next, on this ray AC, I will pick another point D. I'll pick another point D such that the length AP equals the length AD, or the length AD equals, I'm picking another point on the ray AC like D, but I'm choosing this point, such a point that AD equals AP. Okay, so I'm writing it next. Then choose the point, because it's not any point, it's a special point. Choose the point D on the ray AC such that the length of AD is equal to the length of AP. Okay, and finally I'm moving part B to the next page because we need more space on this page. And lastly, I will draw PD. Okay, lastly, draw PD. Okay, I like to put things in order. So let's say, let's put them in order. This is what I did first. This is what I did next. This is what I did third. And this is what I did fourth. Okay. I'm drawing now PD. Now PD, let's say, let PD intersect A, the line A, at point H now. Okay, at point H. So this point is point H. Now, fifth step, I want you to look at these two triangles, PAH and DAH. I'm writing it quickly. In triangle PAH and in triangle DAH, I see that the length AP equals the length AD. The length AP equals the length AD. What else do I see? I see that angle PAH in the first triangle is equal to the angle DAH in the second triangle. So angle PAH equals angle DAH. And lastly, I see that the side AH of the first triangle, PAH, the side AH, let me show it like that. The side AH in the first triangle is equal to the side AH in the second triangle, which is DAH. So AH is a common side for our triangles. And lastly, side AH is equal to side AH because this is their common side. So what do I see here in these two triangles? Side, angle, side. This is great. So if I see side, angle, side, remember our previous video, plane geometry number 8. When I say side and angle side, it refers to the theorem number 3, just the previous theorem, about first sign of congruent triangles. So I continue. So by side angle side, the triangle PAH is congruent to triangle PAH is congruent to triangle DAH. Triangle DAH. Now, once I prove that triangles are congruent, I can now conclude that opposite to equal sides in these two triangles, for example, AP and AD are two equal sides in these two triangles. Opposite to equal sides lie equal angles. Okay? So, it means that the angle PHA, let's write it that way. It means that, let me not write, I didn't like it. Since our triangles are congruent, and in congruent triangles, opposite to equal pair of sides lie equal pair of angles. Pair of angles. So, since our triangles are congruent, incongruent triangles and incongruent triangles opposite to equal pair of sides lie equal pair of angles, the angle PHA must be equal to the angle DHA. But what do you see about angle PHA and DHA? These two angles are adjacent angles, and their sum is a straight angle, which is 180 degrees, right? Since the angle PHA plus the angle DHA is equal to 180 degrees, each of our angles equals 90 degrees. So it means that angle PHA and angle DHA, they are both equal to 90 degrees. So I see that this angle is 90 now. This proves that PH is the perpendicular from P to A. So I showed that, I proved that from any point P, which is not on my line A, it's possible to draw a perpendicular. Here is that perpendicular. If I follow these steps, at the end, in that last fourth step, when I draw PD intersecting A at point H, this PH is the perpendicular drawn from point P to the line A. So PH is the perpendicular actually we can write is a at this time, because we don't know, we haven't proved yet that this perpendicular is unique. We can say, so PH is a perpendicular from P to A. So lesson is too long now. Let's explain the uniqueness of this perpendicular in our next lesson video. Okay, see you next video. Bye. Thank you. Stay with us.